Okay, so what we're doing now is Pythagorean theorem and special right triangles. The Pythagorean theorem is c squared equals a squared plus b squared. And then special right triangles are 45, 45, 90 degrees, or 60, 30, 90 degree triangles. Note that all the triangles we're talking about in this case are right triangles. When you don't have a right triangle, it's another story. So for now, we're looking at these ratios here. In this case, with the 45, 45, 90, we have whatever's on this side is the same as on this side, so represented by x. And then the hypotenuse, which is across or opposite from the right angle, is going to be root 2 times x. So if x were 1 and this is 1 and that's 1, then this would be root 2. If that were 2, this would be 2, that would be 2, this would be 2 root 2, etc., etc. Over here, the 60, 30, 90 degree right triangle, we have a ratio of a hypotenuse is going to be twice the shorter side. And how do we know which is the shorter side? It's the one opposite of the 30 degree angle. So that's the tricky thing here, is knowing that the shorter side is opposite of the 30 degree angle, and that then once you know that the longer side, which is the one opposite the 60 degree angle, is root 3 times x. So if this were 2, if x were 2, this would be 2 down here, that would be 2 root 3, and this would be 4, and so on and so forth. X is the variable. Those are the ratios. The other way it's represented is as 2, 1, root 3, meaning hypotenuse is twice the shorter side, which is, and then the longer side is root 3 times the shorter side. And then over here with the 45, 45, 90, it's 1, 1, root 2. Root 2 is the hypotenuse times the shorter sides. So we're going to look at some examples. This one's a very simple example. What's the value of x in inches of the triangle to the left? Well, if you know your ratios, then you know that this is the shorter side because it's opposite the 30 degree angle. We know this is a 30, 60, 90 degree triangle because 60 degrees completes the 180 degrees that has to make a 180 degree triangle sum theorem. And then x is simply going to be root 3 times 4 because 4 root 3 because of our formula, our ratios. Then if we're asked to find the missing side lengths for both triangles, let's say we had an x and a y we were looking for, then of course that would be twice the shorter side, and y would be equal to 8. So that's the kind of question you get. You're asked sometimes for just one variable, sometimes for both, and you're looking at the ratios. But they get a little more complicated than that. For instance, we get, in this case, find the missing side lengths for the triangle to the left. In this case, this is a 45, 45, 90 degree triangle. And we know that these are the same, but we don't know what they are. We know that this times root 2 equals 7. So if you write that as an equation, then you can start to solve it. So you've got root 2 times x equals 7. We know that because of the ratio. We're solving for x. We're going to divide by root 2. And we get x equal to 7 over root 2. Now, we can't leave radicals like that. We don't want to leave them with a radical on the bottom, so we call it rationalize it. We multiply by root 2 over root 2, and we get 7 root 2 over 2. And that's our answer. So using the ratio in all these cases, sometimes they get a little more complex when you have to deal with radicals. But the key here is to set this equation up properly. And you do that by knowing your ratios. Again, root 2 times times one of these sides, root 2 times x equals 7. We set that up, solve for x, and we get it. And of course, y is equal to the same thing because we know that. All right.